The examples here. If a particle is moving in a square path, if a particle is moving in a square path, this is particle. The particle which is moving in a square path. This is the square path of side A. This is our object. This is our object, and the particle is moving in a square bracket. This is our object, and this object is traveling from here, and this is a square bracket of side A. Square side A. Square side A. If this particle is moving from here, A point, this is the point A, and this is the point B, this is the point C, and this is the point of D. And this particle is moving from here, from A to B. After that, this particle is moving from B to C. After that, this particle is moving from C to D. We have to find the displacement and distance when the particle is the position at A, B, when the particle is position at C, and when the particle is moving at point of C. But the question is that the displacement, find distance and displacement of object when object at A, comma B, comma C, comma D. So we have to draw a simple table here. When the particle is at A, look, when the particle is at A, when the location it has A. When the particle is at A, both the distance and displacement is 0 because the particle is moving from here. When the particle is moving, when the particle is at A, when the particle is at B, when the particle is at C, and particle is at D. Here we write distance, here we write distance, and here we write displacement. So now simple we describe here when the particle is start from A. This is the starting point. When the particle is at A, here it means the particle is starting. Then the distance when the particle is at A is 0 because the particle starts from here, and the displacement of the particle is also 0 because initial and final point is also coinciding here. So both of the distance and displacement will be 0 at point A. When the particle moving from A to B, and the particle reach point here we see this is the distance. How much distance is covered by the particle? That is the means the particle is at A. Distance covered by the object is A. And what is the displacement? Displacement of the particle is also A because this is the initial point and this is the final point. And distance between the initial and final point is also A. Now, when the particle reaches at the point of C, when the particle is reached at the point of C, what is the distance value and what is the displacement value? Here we see that particle is moving from A to B. After that, the particle is moving from B to C. What is the distance covered? Here is the distance is A, and here is the distance of also A, and A. When the particle moves from A to C, the distance is covered by the particle. When the particle moves at the point of C, the distance covered by the object is to A. And what is the displacement? Here is the final point when the particle is finally attained to this point. And where the particle is started from A point. And this is the displacement vector. And here we see that this is a right angle triangle. This is a right angle triangle. This is a distance. This is distance A, and from Pythagoras theorem, this is A. This is A. This is A. From the Pythagoras theorem, we have to apply the Pythagoras theorem. This square plus this square, and taking the root of this value, and now we have to determine the value of this diagonals. So that this length is to be A root 2. Now, what is the displacement here? Displacement is the distance between initial and final point. And this is the displacement here because this is the initial point and this is the final point. And this is A root 2. This is A root 2. And now, finally the particle is coming at the point of D. Now, here we see that the particle cover, here is A distance, here is A distance, here is A distance. The particle cover 3 A distance overall, and at the point of D, when the particle reaches at D, it covers 3 A distance. What is the displacement here? Here we see this is our final point, and this is the initial point where the particle is started, and here we can see that this is the displacement vector, and this is the displacement vector, means this is the displacement is E. Now, here we understand what is the basic difference between the distance and the displacement from the examples. So, we have to see that when the displacement is determining, so we have to first indicate the initial point, after that we have to indicate the final point, and this is the displacement.